Now let's look at graphing a logarithmic equation. Well, gee, that's not something we're familiar with. So let's switch this from logarithmic to exponential form. 2 raised to the number on the other side equals x. 2 to the y equals x is the related logarithmic or exponential equation. Now we can use an xy chart to graph this, and essentially it's the same as what we did earlier with 2 to the x equals y. It's just 2 to the y equals x. So instead of having 2, 4, we're going to have 2 as the input for y, having 4 as the output. If 1 is y, x is 2. Likewise, if y is 0, we have 1. If we have negative 1 here, we have 1/2 on the left, and negative 2 as an input for y gives us positive 1/4 as our x value. Plotting these points, we have 4, 2, 2, 1, 1, 0, 1, that's 1, 0, 1/2, negative 1, 1/4, negative 2. And so this graph is going to have a vertical asymptote on the y-axis. It will never touch that y-axis, and it's going to go upward to the right. And I'd like to identify a couple of points here. First off, I'd like to identify the point 1, 0. I'd also, instead of saying 2, 1, I'd like to call that base, 1. That way we can make a comparison with what we graphed earlier. Previously, we had an exponential graph going through these points here, and if you take a look at this closely, aren't these graphs reflections across the diagonal line y equals x? And isn't that one of the properties of inverses, that they will be reflections across that? And if I have the point 1, 0 and 0, 1, and if I have inverses, I can switch a comma b with b comma a to go from one function to its inverse? Yeah, that is true. Here, the domain of our logarithmic function is going to be from 0 to infinity, not including the 0, and the range will be all real numbers because it goes down forever and up forever. Now let's do some more advanced graphing. We don't want to have to convert this to exponential form, and we don't want to do an XY chart. So that's why I said let's look at our two base points we're going to have of a log base 2 of x. It will go through 1, 0, and it will go through base, 1, which in this case is going to be 2, 1. There's my base of 2 being moved over. Now let's look at what these different numbers 4 and 1 will do to this operation. That 4 out front is going to make the graph 4 times as tall. Well, what does that do? That affects the y value. What we're doing here is transformations. The y value, if I make this point 4 times higher, 0 times 4 is still 0. So the transformation does not affect that point. But the second point becomes 2, 4, because 4 times 1 is 4. That plus 1 at the end is going to move our graph up 1 unit. That's going to take the 1, 0 to 1, 1, and this 2, 4 to 2, 5. Now this is a little bit different. Let me kind of dash in what our basic log base 2 of x graph looks like. This would be the graph without the 4 and the 1 in it. What happened is that 4 out front made this graph 4 times taller. So instead of at 0, it's still at 0. Instead of a height of 1, it's at a height of 4 instead. And so this graph now is kind of 4 times taller, doing this. Then we have to move this graph up 1 unit, so we take this whole graph and shift it up. Notice I've got 1, 1 on the graph. There it is, right there that I've highlighted. And 2, 4 is now going to become 2, 5. So this graph is going to look pretty much like that. Let's try this again, because I know this is strange and new for you. Again, our base graph for a logarithmic function is going to go through 1, 0, and because this has base 3, it's going to go through 3, 1. That's before we have the 1/2, the x plus 1, and the minus 2 considered. And let's also look at that vertical asymptote, which is normally the y-axis, x equals 0, and see how that transforms also. When we do our order of operations in terms of which transformation gets done first, pretend we're substituting a value in for x. The first thing we do is add this 1, then we multiply the half, then we would subtract 2. That's the order we're going to do things in. Now this x plus 1 actually moves our graph left 1 and not right 1. Remember back to graphing parabolas how we had x minus h? This is x minus a negative 1. So that says we're going to move our graph left 1 unit. 1, 0 now becomes 0, 0. The next point becomes 2, 1, and the vertical asymptote is now at x equals negative 1. This 1/2 out front basically says it's going to be half as tall. Well, half of a height of 0 is still 0, so we're still at the origin. Half of a height of 1 will be 1/2, so we're at 2, 1/2. And a vertical stretch or shrink of 1/2 is not going to affect where this vertical asymptote is located, so it's going to remain at x equals negative 1. Then we have minus 2 at the end, which is going to take our graph and move it down 2 units. So 0, 0 is going to shift down to 0, negative 2. 2, 1/2 is going to be at 2, negative 1.5, and the vertical asymptote is still going to stay x equals negative 1. Now let's go in and plot these things. I'm going to begin by plotting the vertical asymptote x equals negative 1, and then 0, negative 2 is 2 units below the origin, and 2, negative 1.5 will be right there. What do we have? We now have that our graph is going to look kind of like this. I probably could have made it look a little bit nicer, but notice how I've taken the original curve that would have gone through 1, 0. It's been shifted 1 left and down 2, and that whole transformation has been done to this graph. Let's try this graphing transformation another time. Okay, again, we look at the base. This is base 4. So our base graph is going to go through 1, 0, and it's going to go through 4, 1. Let's look at the transformations. This x minus 2, that's x minus h, that actually tells us it's moving right 2 units. Well, if it's moving right 2 units, 1, 0 shifts to 3, 0, and 4, 1 is going to shift to 6, 1. If we look at that 3 out front, that means it's going to be 3 times as tall, which affects the y-coordinate. 3 times 0 is still 0, so we're going to keep that point the same. But 6, 1 is going to become 6, 3. This plus 1 at the end is going to represent our graph moving up 1 unit, and so 3, 0 shifts to 3, 1, and 6, 3 shifts to 6, 4. Now, originally the vertical asymptote was on the y-axis. We have a right 2 movement, which moves it to x equals 2, but the other two transformations do not affect it. So I can draw in my vertical asymptote here at x equals 2. I can plot my final points of 3, 1 and 6, 4 on the graph, and know that this graph is going to look like this. Now you can always check it with an XY chart, but that's the fast way to graph these, the shortcut, so to speak.